So now we're gonna use our TI-84 to help us out. And sometimes I start with this unit, and so there might be some calculator stuff, and you're like, yeah, we know that already. Like we've done quadratics, we've graphed, like don't worry about it. So I kind of walk you through these steps again. If you ever want to graph anything, rewrite it. Okay, if you want to rewrite in this form, you press y equals, enter your equation or your equations into y1 or y2. Okay, always clear all old equations. You know that already. A couple notes here. Plot 1 needs to be turned off. That is probably, why is it turned off? Because we're not doing a regression. In linear, actually in this unit, we're not going to do any regressions at all. So for this part, you can just leave it open, turned off. Sorry. Uh, the first value is negative. We use negative, not minus. So keep that in mind, and then just press graph. I think that. So these are just review steps. So I'm going to move on to the next part here. Understanding your window. I'm also not going to spend a lot of time on this because we've already talked about it. If your window parameters are not set correctly, see this line here? It's graphing it, but you just can't see it. So you kind of have to move this over, right, by changing these values, your x-min, x-max, y-min, y-max. Maybe that's a good review, right? So you want to change it so that you start seeing your lines, and especially your intercepts. Okay, you want to see those. So I'm not going to spend a whole lot of time on that. I'm getting to it, so just enjoy this part if you already know what we're talking about. Understanding zoom. Okay, zoom standard or zoom 6. It sets your window. Maybe it's a good zoom standard. The window settings will just be -10 to 10 and -10 to 10, and that being x-min, x-max, y-min, y-max. Everything is set to 10. It's a good way to reset. Zoom fit, right? It will try to make it work, but doesn't always solve your problem. So I should say later on I'll need to do that. Zoom 9 is zoom standard. Plot 1 needs to be turned on. It's when you perform a regression. Okay, we're using L1 and L2. Okay, L1, L2, right? That's regression. That's when we use what's in those columns. That's the only time you would want to use zoom stat. Okay, I would say this. Note. You may still have to change values according to the problem, right? Until you see, right, the intercepts. There you go. So don't think Zoom does it all. You may have to do some adjusting yourself. That's why it's important to understand. Okay? Graphing using technology. So here I'm going to walk you through this unit. Is actually, it can be complicated, but I've developed some steps to help you out. So if you just trust me right now, it's like, why are we going through all these steps? It's to prepare you for what's coming down the pipe. Okay, so we'll look at it, and it says for each of the following, we'll rewrite, graph on the calculator, find the intercepts using technology, determine the y value when x is equal to 7, determine the x value when y is equal to 15. So we're kind of going to do the same thing as we did with the quadratic functions, but now with linear, and I don't think it hurts to review. Finding the intercepts using technology, I think I'm going to just do it by hand. Let me just check here. I made a note for this time around. think I'm going to do it by hand. Yes. So I think I'm just going to cross this out. Okay. I'm going to do that by hand. And I'll already kind of give it away what's going to happen. If you just have one linear equation, you just graph one line, that's it. That's the end of the story. When you have two or more, we call that a system. I don't know if you remember solving systems last year. Do you remember that vaguely? By elimination, by substitution. I don't know if you remember those. So this is much easier. I have to tell you that. It's going to be much easier to solve in this course because we use our graphing calculator. So let's go ahead and do that for each one. So I'll do it for this one. So rewriting, what do I mean by that? I will go 2y, right? The 2y stays on the left hand side and the 6x comes over. Okay, so it's positive 6x plus 30. So if you want to go up here, what we're going to do is we're going to move this over to the other side. That's why the 6 comes over there. The next step would be to divide. Okay? We divide by whatever is in front of the y. So y is equal to 6 over 2. That's just 3x. And don't forget, the 30 back here also gets divided by the 2. That's a common mistake. So that's your rewritten equation. That one is ready to be entered into y1. So this is I guess, the step. And then we'll do the second one, which is graph on your calculator. Let's leave that for later when we're ready to do that. And then so the third step we're asked to do here is find the intercepts. Okay, so this is how I do it. I make a bit of a chart so that it's nice and cleaned up and it's in one spot. These are going to be very important for graphing later on. Okay, so I use this one. You can use either one of these equations. You can use the rewritten one or you can use the original. I tend to always make it go back to this one. It's easier to work with. So here we go. X-intercept. We know that y is equal to 0 at that point. Y is equal to 0, just in brackets like that. So we substitute 0 into that. So it's negative 6x plus 2 times 0 is equal to 30. Let me zoom into that one so you can see better. Right, you substitute 0 in there. So then we're left with negative 6 is equal to 30. We divide both sides by negative 6. X is equal to negative 5. So you've just found the point negative 5, 0. Okay, it's very important that you don't mix up your coordinates. That's your x-intercept. When we're trying to find the y-intercept, we know that x is equal to 0. And if you watch the video, this is no news to you, right? So we just plug in 0 for x, right? So plus 2y is equal to 30. This turns to 0 here, so you're left with 2y is equal to 30. You'll see later on, I don't show all these previous steps how I insert 0. I jump straight to this usually. So y is equal to 15. That's 0, 15. Okay. So, and then I make a nice little box where I just have everything in one place there. So there's your x and y-intercept. Next, it's basically asking if x is equal to 7, what is the y value? Here I will use the calculator. Okay, we're going to use second, trace, value, and we will let x equal to 7. And in turn, we'll find our y. So let's go ahead and type this into our calculator. Go type in the equation that we rewrote, that one right there, we're going to enter that into our y1. So 3x plus 15. That's okay, just like that. And I'm going to graph it. My window is probably not going to work based on what I did before this. It doesn't really work. So what to do here? I'm going to go zoom standard first, like reset my window. So I'm going to go zoom standard. That actually does a pretty good job. Let me see if I can. That does a pretty good job. I still want to see my y-intercept. So I got to go to my window and increase my y max. There's a bunch of hints there. We know that our y-intercept is 15, right? So putting that to 20 is probably a good idea. Setting that to 20. And that's a pretty good window. So I'm not going to change that. Okay. So let's actually find out what we wanted. Second trace 1. X is equal to 7. Y is equal to 36. It's not on our screen, is it? Because 36 is way up here. And in this case, it didn't affect. It was able to do it. So let's just write down y is equal to 36 and we're done. Okay. So we've just found a point, 736. This point is on the line. Okay. Point on the line. The last step, when y is equal to 15, right, what is x going to be there? And in this case, you let y2 equal to 15, and then we go second trace intersection, right? So let's try that. I don't know why I said 15, but anyways, that's our y-intercept. We already know what x is equal to there. Second trace 5, enter, 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 and it is 0, right? X is equal to 0 there. So you found 0, 15, which is the y-intercept. We already found that out earlier, but nonetheless, here it is. Okay. I'm going to ask you to try this exact same thing. This is reviewing what you watched on the video and what I just did now. I want you to do the same thing with this other equation here. You can do check mark here, the double I. We've done that. Double I, we've graphed it and looked at it on the calculator. Can you do the exact same thing? Rewrite, graph on your calculator, find the intercepts, all of that stuff again with this second equation. Pause here for a bit. So I'm going to start going over it and maybe giving you some tricks along the way. What to watch out for maybe in the future. Let's rewrite it. Let's do that first. So negative 5y. I'm going to bring the 4x over, and the 100, I'm going to bring that over as well. Every time you do the bringing over, you change the sign. Some of you do I'm going to add 4x to both sides. I'm going to add 100 to both sides. There's nothing wrong with that. You keep doing that if that makes sense. If that's what you were taught, it's the same thing. We're manipulating this equation, right? So we have the x there already on that right side. Nothing happens to it, but the 4x comes over adding, and the 100 comes over adding as well. Okay, and so you clean that up, you end up with 5x plus 100. Okay, then we divide both sides by negative 5, and you end up with negative x, right? 5 divided by negative 5, and then 100 divided by negative 5 is negative 20. So this is the equation we're looking at, and that should tell you a bunch of things. The slope is negative, so we're expecting, right? We're expecting this because slope is negative, and we know already that our y-intercept is negative 20. So just by looking at it, you already know, have a lot of information about this line. Second, graphing it, maybe I'll wait for that. I'm going to go, this is where I need you to make sure when you're doing the intercepts that it jives with what you have, right? So we're going to go x-intercept, y-intercept like this. And this is a bit of a weird equation, I'm not going to lie, but you should be comfortable with it. So x-intercept, we just turn y into 0. I'm using the original. You know why? Because if you made a mistake in rewriting it, that's going to follow you here. But if you use the very original, that mistake, you'll be like, wait a minute, why are they different? And then you'll be able to troubleshoot and solve your issue. Okay, so we go minus 4x minus 100, and there's the x still on the other side. So that cleans up to negative 4x. I'm going to bring the x over to this side. And you might think that's odd, right? And I'm going to bring the 100 over to the other side. So I'm basically trying to bring all my variables to one side and all the constants to the other side. So that's negative 5x is equal to 100. We divide both sides by 5. X is equal to negative 20. And so I've determined that my x-intercept has those coordinates. Y-intercept, same thing, except for all the x values are replaced with 0, like so. I'm going to zoom into that side so your eyes don't hurt too much. Excuse me. So there we have. Negative 100 equals 0. Negative 5y, bring the constant over to the other side. I would say don't fall into the temptation to skip too many steps, okay? Some students go boom, boom, 2 lines, and then it's like, well, you made a mistake, and now you don't even know where you made that mistake. Okay, take your time. So this would be negative 20. So 0, negative 20 is my y-intercept. So there we go. A little messy, but we got it. And so I'm looking for this part. This is the one you for sure should look for confirmation. Do those two numbers, do they match? If they don't match, you have a problem, right? And then here, we'll just go second trace value, x is equal to 7. We'll figure out our y value here. Let's go ahead and graph that. And so here is it's up to you what you want to do here. We're going to need this equation later on, so I'm going to just turn it off for now. This is how I turn that one off. I just go to the equal sign, hit enter, and then it's off. And then I'm going to enter the new one here, negative x minus 20. And then it'll only graph the second one. And I can't see anything. So, but I know that my y-intercept, I actually know my x-intercept is at negative 20. So I'm going to change my x min to like negative 25. And my y-intercept is negative 20 as well. So my y min, I'm going to change that to negative 25. I'm going to try it that way. And that works pretty good. Right now I'm seeing my graph. Zoom fit would have worked. Zoom standard didn't really help you. But again, use what you know about the situation to guide you as to what to change them to. So second trace 1, x equal to 7, y is equal to negative 27. So you found a point 7, negative 27. Essentially, that's what you did. And then the last one, when y is equal to 15, I'm going to let y2 equal to 15. So second trace intersect. So y2, actually y3, I'm going to make y3 equal to 15 in my case. And I have to make some adjustments here. Okay, I need to see where they meet. Let's see if it does it without. I don't think so. It gives me some kind of error. So I'm going to try this again. I'm going to quit this, hit graph again, change my y min to something further to the left. So I don't know, negative 50. That's probably overkill, but oh no, it's pretty good. So there it is. Second trace 5. Enter, enter, enter. And so x is equal to negative 35. Okay, that's my answer there. Changed x min to negative 50. Okay, that's probably worth reminding you of, right? I changed that to make that work. I noticed the Kleenex box is empty there. If you need tissue, I'm going to put it there later on. All right, keep going. This is where the system comes into play. And really the way we're going to do this is nothing new. So go to 11. Can you write on page 11, we're solving systems? It's just a reminder, that's what you did last year. When you solve systems, you find the point of intersection between two or more lines, okay? Here it is again. Enter each line into y1, y2, and so forth. Press second trace 5, intersect, obviously. Select the first line using up and down arrows. Okay, I'm going to highlight this part. Press enter. Select the second line using up and down arrows because you are going to have more than two. All right, guys, you're going to have more than two. So up and down arrows will jump between one line and the other. So you just have to select the ones you're interested in, then press enter again to start the process. You should see the x and y values for the point of intersection. You may have to adjust your window. I can't overemphasize that. You may have to change your window. Determine the POI for the lines created by the equations above. So I'm going to do this. y1 is equal to, that one was 3x plus 15. y2 is the line negative x minus 20. And then I'm going to go second trace intersect. Grab your calculator. I'm going to clear y3, but I'm going to turn y1 back on just by highlighting the equal sign. If you hit graph, you in this case see both intersections here, like both lines intersecting here. So that's the point we're interested in. That's what you were doing in Intro to Applied and Pre-Cal. Let's try this again. Second trace intersect, and then right now you just have two curves. But look at this. This is important. By default, you're on y1. It says it up here. Everything is in blue font, so you know you're somewhere on this line. You could go sideways, and it would actually stay on it. I'm going to go to the right. I kept on holding the right arrow, and finally I see the cursor. So just remember, you're now on the blue line. Hit enter, and it automatically jumps to the red font, which is your second line. Press enter again, because that's the other one we're interested in. Press enter one more time, and then it will just find the intersection there. And so that is negative 8.75, negative 11.25. This is going to be a very important step for us down the road. Okay. This is called the POI. Okay. POI, what is that? I forgot to emphasize that. POI is point of intersection. So I'm going to go back up here and just call that POI, okay? So if you know that, if I write that down, I'm asking you to find the coordinate of where those lines meet. And then I will also ask you, and this is what we're building towards, is graphing all of the lines on the same grid. Okay, so here we go. Just copy this down. I have my cheat sheet here, right? So I'll just say that the first line, the 3x plus 15, had the following intercepts. That's where the intercepts are going to be very important. -5, 0, and 0, 15. The other line was this one. And that would be -20, 0, as well as 0, -20. This is just an aside here. Okay, so here we go. You need a scale of some sort. Maybe I'll use my ruler to help me out here. So if I'm trying, okay, I'm trying to make sure the -20 and right, these 2 points are going to be way down here, way down to the left. I need to make sure I account for those. So what I'm going to do is I'm going to maybe use a scale of 5. So I'm going to go 5, 10, 15, 20, and maybe go one more just for good measure. And I'll keep that same distance. If you don't have a ruler for now, just try your best to make them spaced out equally. So this is -10 here. This is -20 for that one. So I always like to make sure you make a mark there to indicate those numbers, right? So this is 10 and 20 here. I'm going to use the same scale actually in this case for my y-axis. Keep in mind down the road they might be hundreds or thousands. You just adapt to the situation. So I'm going to put my ruler there, use the same spacing. This is all because of the intercepts that I have, right? -10, -20, +10, positive. So every mark is the equivalent of 5 units. And now I can plot this. I'm going to stick with the first one. -5 zeros right here, make a big dot. 0, 15 is up on the y-axis, make a big dot right there. And that's I'm going to connect those 2 dots. That's all you need for graphing a linear. You just need 2 dots for that, 2 points. Okay, so this is the line y is equal to 3x plus 15. I like to have the labeling on the ends. Don't put them in the middle because you might cross them out with another line that you're graphing. And your second line, it's -20, 0, right? So you go along the x-axis. There it is. And 0, -20, that would be along the y-axis right here. And there you have your system. And don't be shy to extend your lines, okay? Like the grid is just a guide. You can keep going. I actually prefer you extending past those points. This is the line y is equal to -x minus 20. There are so many ways you can check whether or not you're doing this right. Does this look like what's on our calculator? Okay, so I'm gonna try, and I know it's not gonna be perfect, but it does look like it. Okay, is my point of intersection, does that kind of look like -0.875, -11.25? It does, right? It does make sense. is one of them going up and one of them going down, because one has a positive slope, one has a negative slope. So one is dropping from left to right, one is increasing from left to right. So there are a lot of things that you can use to help you out. Is everything on there? Yes. But I'm going to label the point of intersection, this one right here. This one is negative 0.875, negative 11.25. That one is important right now. So there we go. And there's your graphing checklist again. I would strongly encourage you, if you want to score, if you want to get full marks on a graph, make sure you pay close attention to the graphing checklist. Label your X and Y axis. Choose appropriate and consistent scale. Arrowheads if applicable. Label the line with your equation. Okay. So there we go. All right. Now we're going to step it up a bit. Let's go to page 12. We're going to graph not 3, but 4 lines at the same time. Okay, but I'm organizing it a little bit here. Let me just focus. So page 12. Okay, I want you to consider these 4 equations here. Rearrange them, and if you're careful enough, you can do that work in this box. Like my key, I was able, and my writing is atrocious and big, right? So I'm pretty sure you guys can focus or figure out how to make this work. So rearrange them all, right? They should all look like y equals mx plus b, because these are the equations you're going to enter into your calculator. I want you to find the x-intercept by hand, the y-intercept by hand, like on here. I'm honestly going to say for today, I will make this optional. Because, yeah, that part I'm pretty sure you know how to do, like determine what the y value is when x is equal to -5. Like this here, I'm going to make this optional, so you can, for now, just focus on rewriting x-intercept, y-intercept. And then you're going to enter these into your calculator like this: y1, y2, 3, 4. Okay. Once you've done that, you got to watch this. It might seem a little overwhelming, but look at question 2. Determine the intersection between lines y1 and y2. So you want to know where these two meet. Okay, it's just an exercise to get you through it. My advice would be this. You ready? I would turn off y3 and y4 for now, like, so you only see these two, and then find that intersection. The next question is find the intersection between y1 and y3. I would have only y1 and y3 turned on at that point. So that means that yes, you can enter them all. I would enter them all into y1, 2, 3, 4. I would enter them all here, but then just go to the equal sign and only have the ones highlighted that you actually want to see on your graph. If you're up for the challenge of seeing all 4 at the same time, it can also be done. But you just have to be careful. And you have colored screen. I used to teach this with just like black and white, so then it's like which line is which. So I told my students, turn the one off that you don't want to see, right? But you have the benefit of a colored screen. And then once you've done all of this, which trust me, you're gonna have to adjust your window on this one. Okay. And then this is the grand finale, but I provided you a grid and it fits on here if you did everything right. All 4 of them fit on here. The scale is already there. All 4, I want them graphed on here once you're done all your work, right? So unfortunately, you're gonna have to flip back and forth to find your x-intercepts and y-intercepts and transfer them over. I apologize for that, but it is what it is. Okay, so that I'm going to leave you the rest of the class. If you don't finish this today, that'll be your homework. If you feel like, you know what, I need one more go at this, don't panic. I've got you covered. There's on page 14, not 2, not 3, not 4, but 5 equations at the same time. And you do this all over again. And then you have a massive grid on the other side on page 15 where you can do that one more time. Here's what I'm going to say. If you're going to, don't panic too much. Most of our questions are having up to 3 inequality, like 3. Most of our questions go up to 3, not 5 or 4, but some of them do go to 4. 5, I've never had a question with 5. But it's just to practice that skill, finding the intercepts, adjusting my window, doing that kind of stuff. Okay, finding x and y intercepts. Okay, so page 12 to 13 for sure, and then 14 to 15, that's up to you how far you want to push it. All right, I'm going to pause it here for now.